Am I audible properly, guys? Okay, shall we start? Okay, so let us start, guys. Today I will start the second chapter, and the topic is second chapter name is linear time invariant system, LTI system, and first of all we will study the continuous time convolution. Okay, and this is also very much important topic. So tell me, am I audible properly? Audio and video both are clear to you people? Okay, so let us continue with this chapter. So topic name is continuous time convolution, and there are total 3 topics in this chapter: continuous time convolution, discrete time convolution, and properties of an LTI system. Okay, so let us start with the very first question. Let us start with the topic. Now LTI system, guys, what do we mean by LTI system? A system which possesses the property of linearity, and if it is a time invariant, then it is said to be LTI system, linear time invariant system, guys. LTI system, a system which satisfies property of linearity, and if it is time invariance, is known as linear time invariant system. And why we are studying only linear system and time invariant system? So there are mainly 2 reasons to study LTI system. Reason number 1 is most of the physical process possesses these properties, and reason number 2 is an LTI system can be represented in the impulse response. This is very much important. Any kind of LTI system we can represent it in impulse response. So these are the mainly 2 reasons to study LTI system. Okay, later we will study what are the condition, and we can say what is the condition for LTI system to be causal, non-causal, static, dynamic, stable, unstable, under which condition or under what condition the given LTI system is stable or invertible or static or dynamic, we can say, or causal, non-causal. That also we will study. But here LTI system is a system which is linear in nature, and if it is time invariant. Okay, so now next is, see, now LTI system we are giving input x of t, and for this input this system produce y of t. So here I wrote h of t. So this system is represented, this system characteristic is represented in the impulse response h of t, guys. Like x of t is one kind of input signal, y of t is one kind of output signal. So similarly h of t also we can say one signal, but it represents the system characteristic, or we can say it is a system response, or we can say it is a impulse response. H of t is what? Impulse response, which describe the system characteristic. Okay, so if you are giving impulse input like unit impulse, x of t equal to impulse, then output is known as what? Impulse response. Or vice versa also true. Suppose if you want to find impulse response, then input should be impulse function. Suppose if you are giving unit step input, then system produces whatever the response, it is known as unit step response. Or reverse statement, like if he wants to calculate or if he wants to find the unit step response, the input must be unit step. Okay, now unit ramp. So if input is unit ramp, then output should be unit ramp response, and if input is unit parabolic, then output is what? Unit parabolic response, guys. Okay, now let us understand the impulse response and the step response. First I am saying the impulse response. Now before that, some important Laplace transform that you have to remember. Entire Laplace transform also we will study, complete Laplace transform, but basic Laplace for this chapter, just remember this thing. Laplace transform of impulse function This is time domain signal, and here it is in the frequency domain, or we can say Laplace domain, S domain, frequency domain. Clear? Okay. In frequency domain, if input signal x of t equal to del t, then Laplace transform of del t is nothing but 1. And if input signal x of t equal to u of t, that is the Laplace transform of unit step function is 1 by s, and the Laplace transform e power minus at into u of t is nothing but 1 upon s plus a. Here minus a, then here plus a. Suppose here plus a, then it become s minus a, okay. Now suppose actually here we want to find the relationship between x of t, h of t and y of t. X of t is input, y of t is output, and h of t represent the system characteristic, and it is known as the impulse response. So we want to find the relationship between y of t, h of t and x of t in the time domain. Okay, let us consider the Laplace transform of this h of t is nothing but h of s, and it is known as, let us say for example 1 upon s plus 3. Let us take Laplace transform of input signal. Laplace transform of input signal is x of s. X of s, guys. Laplace transform of output signal, let us consider y of s. Okay, and Laplace transform of h of t is h of s. Now in s domain, let us take the relationship between x of s, y of s and h of s is nothing but what? Output y of s is multiplication of input x of s and the Laplace of impulse response h of s. This is the relationship between x of s, h of s and y of s in the s domain, multiplication, simple multiplication. Okay, now as I told guys, if you want to find the impulse response, then output should be impulse. So first I am going to find the impulse response. Now first I want to find the impulse response. We want to calculate the impulse response. So for impulse response, I told you guys, input should be what? Impulse. Input should be impulse. Then in this case, whatever output you are getting, it is known as what? Impulse response. IR I am writing, I dot R, impulse response, correct? It is known as what? Impulse response. Whatever output we will get, that is known as impulse response. So what is the Laplace of this x of t? X of s is equal, Laplace of impulse function is 1. It is 1, guys. So here y of s is equal to x of s into h of s. So we can see here y of s, what is x of s? 1 into h of s, guys, and y of s is nothing but what? Impulse response. See, Laplace of impulse response. So inverse Laplace transform, here it is y of t and here it is h of t. So I told you guys, see, this is nothing but impulse response. Y of t I told, here impulse response. So y of t, here it is impulse response. Okay, so y of t impulse response. So h of t also we can see impulse response. So that's why I told you h of t is nothing but what? Impulse response, which define the system characteristic. See, y of s equal to h of s equal to 1 by s plus 3, 1 upon s plus 3, correct? So here impulse response consists only system parameters. Y of s equal to h of s, which is equal to 1 upon s plus 3, only system parameters, because here Laplace of input is 1, that's why. So here h of t we got, h of t is nothing but what? Impulse response. H of t is nothing but what? Impulse response, guys. Similarly, if you want to calculate, suppose if you want to calculate the unit step response, then input should be unit step. X of t equal to u of t, Laplace of u of t is 1 upon s, x of s equal to 1 by s, it will be y of s equal to h of s by s, correct? So you will get the unit step response. Okay, so here h of t is nothing but what? Impulse response. So conclusion is what? What is the conclusion here? Now see, unit step response also we will see. So Laplace y of s, output y of s is equal to x of s into h of s. So y, for now unit step response guys, first we want to calculate the, this is the impulse response, correct? First we calculate impulse response. Now next is unit step response. So for unit step response, x of t should be u of t, then whatever the response you will get, y of t, in this case it is known as unit step response. USR means unit step response. Okay, so here y of t is equal to y of s, not y of t, y of s is equal to here x of s. What is the Laplace of x of t guys? So Laplace transform of x of t is nothing but x of s, which is equal to Laplace of u of t. Laplace of u of t is 1 by s. So here y of s is equal to x of s is nothing but 1 by s into h of s. Okay, so y of s is equal to, it is not equal to h of s guys, it is h of s upon s, correct? H of s upon s. So this is the unit step response. So here unit step response is not equal to h of t. Here y of t equal to not h of t. In previous case we got y of t equal to h of t. So that's why h of t is impulse response. But here you can see y of s equal to h of s by s. It is not equal to h of s. So that's why we cannot say unit step response is the system response. Okay, or we cannot represent this system by the unit step response. We can represent this system by the impulse response only guys, correct? It is represented by the impulse response only. So in this way we can calculate the impulse response. Then you can put the value of h of s, then you can do the part subtraction and you can find the y of t. Okay, inverse Laplace then y of t, that later we will see. Okay, so important part is what? If you give the input x of t equal to del t, then y of t will be h of t, which is nothing but the impulse response. Fine, clear to each and everyone? Okay, very good. Now the conclusion part is, now first we will study the continuous time LTI system. Input is x of t, continuous LTI system, and output is y of t. So h of t is nothing but, it is the impulse response. This system is represented by the impulse response. This is nothing but the impulse response. Okay, now we want to find the relationship between x of t, h of t and y of t. Okay, so here I am writing, see, y of t is nothing but transformation on x of t. Y of t is nothing but transformation on x of t. If, already we know that if x of t is equal to del t, correct, then in this case, then y of t is equal to h of t, just we have seen. If input is impulse, then y of t is nothing but h of t. Okay, so here y of t is equal to here I am writing ki y of t, if you replace x of t with del t, correct, if you giving x of t equal to del t, then it will be h of t guys, it will be what, h of t, correct. So we can write like this, h of t is equal to transformation on del t. And if you replace, suppose left hand side t become t minus tau, because we want to use it later, t become t minus tau. Left hand side we are replacing t with t minus tau. Left hand side we are replacing t with t minus tau. So right hand side also everywhere we have to replace it with t become t minus tau. So later this result we will use later. Okay. So h of t minus tau is equal to what? Transformation on del t minus tau. Now here y of t is equal to transformation on x of t. Y of t is equal to what? Transformation on x of t. Y of t is equal to transformation on x of t. Okay. Transformation on x of t. Now remember the first chapter, property of the impulse function, last property, shifting property of the impulse function guys. Last property, any general signal x of t can be represented in weighted and shifted impulses. Do you remember? Integration tau is from minus infinite to plus infinite. Tau is from minus infinite to plus infinite. X of tau into del t minus tau d tau. Do you remember this property? Any general signal can be represented in weighted and shifted impulses. So replace x of t with this equation. So y of t is equal to transformation on integration tau is from minus infinite to plus infinite x of tau into del t minus tau d tau. Okay. So give transformation to either x of tau or del t minus tau, any one signal. Okay. So for simplicity I am giving this transformation on del t minus tau. So it will be y of t is equal to integration minus infinite to plus infinite. Variable is tau. So x of tau into transformation on del t minus tau d tau. Okay. Now already we know that what is this guys? This is nothing but what? This is nothing but transformation on del t minus tau is nothing but h of t minus tau. So it is nothing but h of t minus tau, h of t minus tau. So here y of t is equal to integration tau is from minus infinite to plus infinite x of tau into h of t minus tau d tau. So this is the relationship between x of t and h of t. Okay, and by definition this is known as the convolution operation between x of t and h of t, between two signals. So one signal is x of t and h of t also one kind of signal only. So it is nothing but convolution operation between two signal is y of t is equal to x of t and convolution notation sign is asterisk mark h of t. So this is convolution operation. This is what? Convolution. Convolution between two signals. Convolution operation. Like it is same as, it is a one kind of mathematical operation, same as addition, subtraction, integration, differentiation, multiplication, division. Okay, this is also one kind of mathematical operation guys. Okay. So y of t is nothing but x of t convolution h of t, and this is the formula to find convolution between two signal. One signal is x of t and another signal is h of t guys. Okay. Okay, very good. Now property guys, property. See, property is what? So we got y of t is equal to x of t convolution with h of t. Okay, now we know that if input x of t is del t, then what about output? It is nothing but what? Del t convolution with h of t. So input, if you replace x of t with del t, then output will be what? H of t only. Output will be h of t only guys, correct? If you replace x of t with del t, if you replace x of t with del t, then it is nothing but what? H of t only. It is h of t only guys, fine. So here, from here we can take one important property of the impulse function. What you can say? See, h of t convolution with del t. Now here commutative property also we can use. Commutative property means what? Here you can interchange del t and h of t. There is no issue. Like x1 into x2, which is equal to x2 into x1, is same as del t convolution h of t, which is equal to h of t convolution del t. So here what we can write? Del t convolution with h of t is equal to h of t. Okay, you can interchange del t and h of t also. So h of t convolution with del t equal to h of t. See, h of t is also one kind of signal. So instead of x of t, can we write like this? X of t, instead of h of t, we can write x of t. So replacing h of t with x of t, convolution with del t is nothing but x of t only. So this is the convolution property of the impulse function. Convolution property. Okay. So convolution of any general signal with impulse function is nothing but that general signal only guys. This is the conclusion. Okay. Now here one more, no, two more properties guys. See, this is for the what? Linear time invariant system. Time invariant means what? If input is delayed by certain seconds, then output also delayed by same seconds. Like if input is delayed by 2 seconds, then output should be delayed by 2 seconds if it is time invariant. So what exactly I am saying? Suppose if I am delaying this signal by t1 seconds or advanced by x of t by t1 seconds, then this is the output. We can say this is the output. So this output also delayed by the same second. If here t become t minus t1, the output also delayed by t become t minus t1, delayed by the same t1 second. Similarly, let us take this input x of t convolution with del t minus t1. If this is a delayed by t1 second, again this is time invariant system. So that's why output is what? Delayed by, output is x of t, this is delayed by t1 second, correct? And suppose this is delayed by, suppose t1 second, and this is delayed by t2 second. Okay, delayed by 2 second, delayed by again 2 second. So overall output is delayed by 2 plus 2, 4 seconds. So we can write x of t minus t1 minus t2. Okay, so it will delay by 2 seconds and again 2 seconds, so total 4 seconds. So this is delayed by t1 second, delayed by t2 seconds, so overall it is t1 minus t2. Suppose here it is plus, then here plus guys. So these are the important properties of convolution of any signal with impulse function, or we can say convolution property of impulse function guys. Convolution property of impulse function. Now see, in first chapter we have studied this concept. Any general signal x of t is multiplied with impulse present at t naught. Multiplication property of impulse function. Then it will be what? X of t naught into del t minus t naught, correct? X of t naught into del t minus t naught, fine. And here we got the convolution property. Convolution of any general signal. Convolution, see, this is the multiplication property of impulse function. Now this is the convolution property, del t minus t naught. Okay, this is delayed by t naught second. So here output is what? X of t minus t naught. So these are two important properties. Is this clear? These are the two important properties. Fine. So this is the multiplication property or product property, and this is the convolution property of impulse function. And these both are very much important to solve the question. Let us try first question, guys, based on this property. See how to solve this question. So this is the signal x of t e power minus 2t equal to of convolution with t minus 3, guys. Okay, t minus 3. So here simply what you have to do, guys, according to the property, suppose output is y of t. So y of t is equal to what? Here t minus 3, guys. So if it is x of t, see, let us consider standard method is what? Let us consider this is x of t. So here it is x of t convolution with del t minus 3, which is equal to what? X of t minus 3. Now this is x of t, guys. So what is x of t minus 3 here? So here output, let us consider y of t. We got x of t minus 3. X of t minus 3, correct? So simply what you have to do, here t become t minus 3 everywhere. See here t become t minus 3. So here also everywhere t become t minus 3. So e to the power t become t minus 3. T become t minus 3. Everywhere replace t with t minus 3. Replace t with t minus 3, guys. Fine. So this is the answer. Similarly, see what you have to do. Simply t minus 3 here. So replace t with t minus 3 everywhere. Okay. Now this one, guys. Here del 3 minus 2t. So first of all you have to use the scaling property of the impulse function. Before applying any property of impulse function, first of all use the time scaling property of the impulse function. Time scaling property. Okay. So here solution, see, y of t is equal to del t minus 3 convolution. Here scaling factor is minus 2. So 1 upon mod minus 2 first chapter. So t minus 3 by 2. T minus 3 by 2. So it will be here, see, this is signal t minus 3. So this is 1 by 2, guys. And here del, this is t. So replace t with what? Here t minus 3 by 2. Correct? Replace this t with what? T minus 3 by 2. So this is 3 by 2 and this is minus 3. So y of t will be 1 by 2 del t minus 9 by 2. Correct? Fine. Okay, very good. Now let us take one more question based on this. So try this question, guys. U of t minus 3 convolution with 3 minus t, guys. So again, before using any property, first use the scaling property of impulse function. Tell me your answer in the comment box, all of you. So here y of t, first time scaling property of impulse function, u of t minus 3 convolution. Scaling factor is minus 1. So 1 upon mod minus 1 del t minus 3. So here it is y of t. This is 1, guys. And u of, replace t with t minus 3 and this is minus 3. Replace this t with t minus 3. So answer will be, it is u of t minus 6. Answer is what? U of t minus 6. Here guys, similarly here, question number 4. So this one. So again, first of all, time scaling property guys, because scaling factor is minus 1 and impulse is a even function. So e to the power minus 2t u of t minus 2 convolution with del t minus 1.5, because impulse is a even function. Impulse is a even function, you can take minus sign outside the bracket. Okay, it will be 1 upon mod minus 1, so it is 1. Now here replace t with everywhere. This t with what? T minus 1.5. So output y of t is equal to e to the power t minus 1.5 into u of t minus 1.5 minus 2. Okay, so y of t is equal to e to the power minus 2t plus 3 guys. See, minus 2t plus 3 into u of t minus 3.5, u of t minus 3.5, correct? So in this way we can solve this type of question. Okay, convolution property of impulse function, this is known as what? Convolution property of the impulse function. Let us take one more question, two more question here. Again same thing. Again, first of all you have to take the minus sign outside. Impulse is a even function, so t minus 2 convolution with del t minus 5, which is equal to, see, t minus 5 and t minus 2, so it is del t minus 7, del t minus 7 guys, correct? Del t minus 2 convolution del t minus 5, it is what? Del t minus 7. Simple. Replace this t with t minus 5 or replace this t with t minus 2, both are same, correct? So it become what? T minus 7 directly you can write. Now here again, before applying any property, first of all you have to use the time scaling property. Okay, so here scaling factor is 4, so 1 by 4 del t plus 1 by 2 convolution with u of t plus 4. So y of t will be, see, 1 by 4 del t plus 1 by 2, so replace t with what? T plus 1 by 2, so 1 by 4 u of t plus 1 by 2 plus 4, so it is 1 by 4 into u of t plus 9 by 2, t plus 9 by 2. So answer is what? 1 by 4 t plus 9 by 2, correct? T plus 9 by 2. So this is your correct answer. Fine. I hope all the students are getting. Now next is different properties of impulse function guys. This is also very much important topic. Different properties of impulse function guys. Different properties of convolution. Different properties of continuous time convolution. Okay. So first property is what? Commutative property. This property says that if the convolution of x of t signal with h of t is equal to y of t, and which is given by integration minus infinite to plus infinite x of tau into h of t minus tau d tau. Then according to this property, you can change x of t and h of t. That means if you perform the convolution between h of t and x of t, like h of t convolution x of t, which is also equal to same answer you will get, y of t, and it is given by minus infinite to plus infinite. Now h of tau into x of t minus tau d tau, same answer. In both the cases you will get the correct answer or same answer. See how to prove this property. Simply replace this t minus tau with lambda and then continue, and you will get this answer. If you replace, see, lambda with t minus tau, so here tau is equal to t minus lambda. So here tau is equal to what? T minus lambda. Here t minus lambda, so you will get what? T minus tau. Again we will replace lambda with tau, correct? So you can prove this property, but proof is not necessary in every case. Simply you have to remember the property, and you have to remember how to use this property effectively. Okay, fine. So this is what, guys, commutative property. You can interchange x of t and h of t, will get the both same answer in both the cases. Fine. Next property is distributive property. This is also very much important property, guys. So according to the distributive property, here if x of t convolution with h1 of t plus h2 of t, that means first we are doing the summation of h1 of t and h2 of t, and then the resultant signal will be convolved with x of t, then suppose it produces y of t. Now what you can do, guys, you can open the bracket. That means first perform the convolution between x of t and h1 of t, then perform the convolution between x of t and h2 of t, then individual you can add, then also you'll get the same answer. So which is equal to what? X of t convolution h1 of t plus x of t convolution h2 of t, you will get the same answer in both the cases, correct? You will get the same answer. Fine. So this is what? The distributive property. Next property is associative property. Okay, associative. So according to the associative property, x of t convolution h1 of t convolution h2 of t, which is equal to y of t. If x of t is convolution h1 of t convolution h2 of t, that means what? First perform convolution between h1 of t and h2 of t, and the resultant signal is being convolved with x of t, then it produces y of t. So first what you can do? First you can perform the convolution between x of t and h1 of t, then the resultant signal is convolved with what? h2 of t, then again it will produce the same answer, y of t, guys. So this is what? Associative property. Fine. Associative property. Now next property is time shifting property. Yes, this is very much important property, guys. This is very much important property. So according to this property, if convolution of x of t with h of t is y of t, then we are discussing this thing for the time invariant system. Time invariant means what? If input is delayed by 2 seconds, output should be delayed by 2 seconds only, if it is time invariant. So see, if you are replacing this h of t is delayed by t1 second, then output y of t should be delayed by t1 second. If it is plus here, then here also it should be plus. Similarly, if x of t is delayed by t1 second, like this, you are replacing t with t minus t1, then output also what? T minus t1. Now suppose here this x of t is delayed by t1 second, h of t is delayed by t2 second, then output will be delayed by what? t1 minus t2 second. That means what? t1 plus t2. If you take minus sign common, then overall it is delayed by t1 plus t2 second. So this is very much important property, guys. It is known as the time shifting property. Okay, time shifting property of the continuous time convolution. Now next, guys, this is also very much important property. It is known as what? Differentiation property. See, if convolution of x of t with h of t is y of t, and Again, this is also linear system, guys. So if you differentiate x of t, first order difference of x of t with respect to t, then output also differentiated by t with first order differentiation of y of t, guys, dy of t by dt. Suppose differentiation of h of t, then output also differentiate by h of t, guys, sorry, differentiate with t with respect to t, guys, dy of t by dt. And here dx of t by dt, dh of t by dt. So this is the first order, this is the first order, so it will be what, this is what, second order, d square y of t by dt square. Suppose it is differentiated by this is mth order, here differentiation of mth order, here differentiation of nth order, then output will be what, overall it is differentiated by what, m plus nth order, guys, differentiation. Fine. So this is the differentiation property, guys, differentiation property, which is very much important to solve questions. Okay. Now next, guys, next is what, time scaling property, number 6. It is number 6, guys. So time scaling property. So according to the time scaling property, if x of t convolution with h of t is y of t, then time scaling t become at here, replace t with at, here also t with at, guys. Make sure the scaling factors should be same, guys, in both the case, x of t and h of t, the scaling factors should remain same. So x of at convolution h of at, which is equal to what, 1 upon mod a y of at, guys. Okay, scaling factor should remain same, guys. If scaling factor is different, then this property is not valid here. Okay, so this is not what, number 6, time scaling property. So these are the different properties of the impulse function. Now we will solve some question based on this property, guys. Correct? Based on this all properties, we will solve some questions. So first question is convolution of u of t with u of t. So using the standard method, using the standard formula, or graphical method, analytical method, you can solve, and by the property also you can solve the question. Fine, by using property also. So how to use the property? We know that the differentiation of impulse function, we know that the convolution of impulse function with any function is nothing but that x of t only. Convolution of x of t with del t is nothing but x of t only. So here differentiation property I will use, y of t is equal to u of t convolution with u of t. Okay, so here differentiation dy of t by dt, first order differentiation. So here also du of t by dt convolution with u of t, convolution with u of t. Fine. So we know that in first chapter we studied the convolution differentiation of step function is nothing but impulse function. So dy of t by dt, dy of t by dt, which is equal to, this is nothing but impulse function del t, and here convolution u of t. Now we know that convolution of impulse function with u of t is nothing but u of t only, so which is equal to u of t. So here dy of t upon dt equal to u of t. Now both these are integration. So here integration minus infinite to t. Here if you do the integration, then y of t is equal to integration minus infinite to t, guys. Integration is from minus infinite to t, and here it is u of tau d tau. Now we know that what is the integration of unit step function. If you integrate unit step function from minus infinite to t, guys, integration of unit step function from minus infinite to t, then it will be what, ramp function. Or if you replace, see, this u of tau, it is 1 for tau greater than 0 only. So y of t will be integration 0 to t, this is 1 d tau. So it will be what, guys? It will be t, and again this is also for t greater than 0 because this is for u of t. Okay, so it is nothing but what? T greater than 0 means what? T for t greater than 0, and it is 0 for t less than 0. So it is nothing but the ramp function, t into u of t, we can say ramp function t into u of t. Why u of t? Because this is for t greater than 0, that's why u of t. So and it is nothing but your ramp function r of t. Okay, so convolution of u of t with u of t is nothing but r of t, guys, ramp function. Convolution of step function with another step function is nothing but r of t ramp function. Fine, this is the first question. Now next, e power minus 2t u of t convolution u of t. This is exponential decreasing function, convolution with step function. Here also, guys, we can use the analytical method, graphical method. By the property also we can solve. So using property of impulse function, differentiation property. So see, out of two signal is one signal is step function, then use the differentiation property, because differentiation of step is impulse and convolution of impulse with any signal x of t is nothing but that signal x of t only. So it will be very much easy for you. So y of t e to the power minus 2t convolution with u of t. Now differentiation, first order differentiation. So out of two signal you can differentiate any one signal, but it would be better to differentiate u of t because differentiation of u of t is the impulse function. So e to the power minus 2t u of t convolution with du of t upon dt. So here e to the power minus 2t into u of t convolution with, this is the impulse function, del t. So again, convolution of any signal, convolution of any general signal with impulse function is nothing but that general signals only. So here it is nothing but e to the power minus 2t u of t. So y of t is equal to here integration minus infinite to t e to the power minus 2t u of tau d tau. Okay, u of tau d tau. So again, u of tau is equal to 1 for tau greater than 0. So you replace, if you replace u of tau with 1, guys, then limit will be 0 to t, and this is for the t greater than 0 only. So here y of t is equal to e to the power minus 2 tau divided by minus, and this is for t greater than 0 only, guys, because of u of tau. Because of u of tau, this is for t greater than 0, and for t less than 0, answer is 0. So here, so it is 1 minus e to the power minus 2t divided by 2, and this is for t greater than 0, so simply you can multiply u of t. So convolution of e power minus 2t u of t with step function is nothing but what? 1 minus e to the power minus 2t divided by 2 into u of t correct? So this is the right answer. This is the correct answer. Fine. Now next, see here. Convolution of, now important result guys. Important result. Okay. So we got del t convolution with del t, which is nothing but del t only. Okay, we know that convolution of unit step function with unit step function is nothing but u of, sorry, del t u of t only. Fine. And just we got u of t convolution u of t is nothing but r of t. Okay, now time shifting property I am using. Suppose if this function is delayed by t1 second and one more step function is, another step function is delayed by t2 second, correct, then the ramp function will be delayed by t minus t1 minus t2 guys. So first what you have to do, find the convolution without shifting. Without shifting, find the convolution, and then you can do the shifting in y of t, overall shifting. You can perform overall shifting in y of t guys. Okay, so see some question based on this. This is very much important property. See, let us solve some question. Suppose this is given. Now next is r of t convolution u of t. See, r of t, what is the convolution of ramp function with u of t? Okay, so here y of t is equal to r of t convolution u of t. So again, one signal is u of t, so differentiation property dy of t by dt. Okay, so here r of t convolution of du of t by dt. Fine. So here this is impulse function del t. Okay, so r of t convolution del t is nothing but what, r of t only. So dy of t r of t only. Fine. So here y of t is equal to integration, correct, both side integration, minus in by 2 t r of tau d tau guys, r of tau d tau. Fine, r of tau d tau. Now r of t is nothing but t into u of t. This is t into u of t. So r of tau equal to tau into u of tau. Again, if you replace u of tau with 1, then the limit will be 0 to t, and the result will be for the right side, that is for t greater than 0. This is for, because for t less than 0 answer is 0, for t less than 0 u of tau is 0, so that's why integration answer also 0. So it is tau d tau, and again this is for t greater than 0 only. So here it is tau square by 2, this is 0 to t, so it will be t square by 2, and it is for t greater than 0. So it is here multiplying u of t. So convolution of ramp with u of t is nothing but what? Parabolic function. It is t square by 2. T square by 2 into u of t. Correct? T square by 2. Fine. It is t square by 2 into u of t. Okay. Now here next question. Now see, this is very good question, guys. Here this is very good question. E power minus 2t u of t convolution with u of t minus 3. Now as I told, guys, if shifting is present here, then first find answer without shifting. Without shifting means what? Suppose y of t is equal to, or see, without shifting means here e to the power minus 2t and here u of t. Without shifting means simply convolution with u of t. Convolution with u of t. So we know that convolution of this function 1 minus, already we have solved this, e power minus 2t divided by 2 into u of t. U of t. Now if it is delayed by 3 seconds, then output should be delayed by 3 seconds, guys. So we can write it here, e to the power minus 2t into u of t, convolution with u of, replacing t with t minus 3. This is delayed by 3 seconds, so output should be also delayed by 3 seconds everywhere. 1 minus e to the power minus 2 t minus 3. Here also t become t minus 3. Even here also, guys, everywhere t become t minus 3. So this will be your answer, guys. This will be your correct answer. Fine. Okay. So in this way we can get the answer. First of all, find the answer without shifting. Find answer without any kind of shifting, guys. Then you can replace t with t minus 3. Left hand side this t become t minus 3. Right hand side also everywhere t become t minus 3, guys. Output also delayed by 3 seconds. Fine. Okay. Because this is for time invariant system. This is for the time invariant system. Okay. Now see, you can solve one more question. One more question, guys. See here in this result, suppose if I am multiplying with k1 amplitude scaling, u of t minus t1 convolution with k2 u of t minus t2, which is equal to, it is what here, see, k1 and k2. So if you see the formula between convolution between two signals, then multiplication x of tau into h of t minus tau. So that's why here k1 into k2 will come into picture. So here k1 is the amplitude scaling factor, k2 also amplitude scaling factor. So k1 into k2, guys, and it is r of t minus t1 minus t2. Correct? R of t minus t1 minus t2, guys. Okay. So remember this thing. So based on this question, let us solve this question. So you can see here k1 equal to 3, k2 equal to 5. So we know that convolution of u of t, as I told you, first of all find the convolution. चलिए, so u of t convolution with u of t, we know that it is r of t guys. Okay, so here it is t3 into u of t minus 2 convolution with 5 into u of t plus 5. So it will be what? 5 into 3 guys. So 3 into 5 into r of this is t minus 2 and here plus 5 guys. So answer will be, it will be 15. It will be what? 15 r of t plus 3. So ramp function starting from minus 3 going towards right side with the slope, increasing slope, plus 15 guys. So answer will be 15 r of t minus 2 t plus 5. So it will be t plus 3 guys. Very much easy. Fine. Okay. Okay, so guys, let me finish this lecture here, and all of you, thank you so much watching me live on Gate Wallah English channel, and please provide your valuable feedback after completion of this session, and next part we will continue into subsequent module. Thank you guys, thank you so much.